So let's play a quick game. Okay, so these are three different colored balls are given to you. One is orange, one is green, and the last one is black. Okay, now you have to select one ball from these three balls. Okay, select one in your mind. Okay, you can say it loud. I'm not able to hear you at this point, right? So yeah, selected, done. Okay, now I have got this bowl, okay, in which three sheets are there for all these three colored balls. Okay, now I will open any one sheet randomly and let's see who all win. Okay, so I have selected one sheet and orange is the winner of this game. So yes, those who all selected orange color, congratulations, you all have won this game. Okay, so what did you do? First thing, you selected one ball from these three different colored balls. Yes, and then the ball needs to be orange colored one. That's what my condition is, right? Okay, so let me get to the point. Yes, so first thing, what did you do? Selected one ball, right? Select one ball. Select any one ball of it out of these three, correct? And what was the condition for this? It has to be orange colored ball. Okay, the ball needs to be orange colored. Yes, so when you are saying this, you have to select one ball, right? So how many options do you have for this? You have got three options, right? Either you can select orange, or you can select green, or you can select black, correct? Yes, and when you are saying that this specific event, the selected ball needs to be orange one, then obviously you have got how many options? Orange only, right? In this case. Now understand this, okay? Whatever is the generalized operation you are doing, that is known as experiment. That is known as experiment, okay? And whatever is the specific action or specific operation or specific activity you are doing from this experiment, that is known as event. That is known as event. So one point is clear from this, right? This event is always going to be what? Subset of experiment. Yes, see now, because experiment is something huge operation which is going to give you a set of outcomes, correct? So in our example, this is the set of outcomes you get out of the experiment, and then event is going to be give you a specific set or one subset from that experiment. Okay, so now whatever you get, this set, right, that is known as sample space. Okay, technically when you are studying probability, this set which you have formed from this experiment is nothing but your sample space. This is indicated by S, correct? From this initial letter, sample space S, okay? And whatever set you get from the event, that is known as event, E, that is indicated by not just E but any capital letter would do. But then popularly E is used for better understanding, right? If there are more than one events, then you can go like E1, E2, E3, A, B, C, D, no problem. But just do not indicate this by S, otherwise it will be a confusion for you, correct? Because S is nothing but your sample space, E is your event. Clear up to this? You got my point? Now, how many items are there in your sample space? How many are there? 3. You can see that, correct? So N of S is what? 3. Yes. Total number of outcomes are 3. And what are the outcomes of event from this favorable event? That is 1 in our example. Correct? Correct up to this? Okay. Now understand the next point. Okay. Now, what are the chances to win this game? Okay, we played a little game, correct? You selected one ball, say you selected black one, but then those who selected black, they lost the game, correct? Those who selected orange, they won the game, correct? Now say, you are the one playing this game, so what are your chances to win this game? There are 3 options, out of which 1 is correct, right? You getting my point? So what are the options? Out of 3, 1 is correct. So these are your chances to win this game, because total there are 3 options and 1 is correct out of it. This is nothing but what? This is nothing but what? N of E, yes, divided by N of S. Am I doing it right way? Yes, you can represent it this way, correct? So total number of favorable outcomes divided by total number of outcomes, correct? This is sample space. This is the specific event. Yes, so these are your chances of winning the game. Okay, so chance is nothing but probability. Okay, this is as simple as that. Okay, remember, probability is a more mathematical name for chance. Chance is a like, you know, it is very generalized name, right, that we use in our day-to-day life. But chance is nothing but probability. So as we are studying probability, we will replace this chance by probability. So what did you just find? You found out the probability of that event E. Is this right? Chances of E, correct? Chances of getting orange ball, right? Chances of winning the game. You just found out that. So that gives you the formula for your probability. That's the only formula there. You don't have to mug it up. See, we just derived it, right? Logically only, right? We didn't really mug it up. So what is the probability of event P of E equals to N of E divided by N of S? Probability of an event equals to total favorable outcomes divided by total outcomes, correct? Okay, so these are some basics of probability which you should know before solving any problem on probability. Also revise permutation and combination very well, because probability is very much dependent on this P and C topic, correct? So you have to revise that once. So moving little bit further, let's see, there are some more categories of experiment, right? When you are saying experiment, there are mainly two types of experiments, okay? One is deterministic experiment, and the second is random experiment or probabilistic experiment. Okay, now I will tell you the exact difference between these two. Okay, now in this case there were three different colored balls, correct? And that's why you were not sure about the outcome, and that is why you had to find out the probability of winning this game, correct? Now assume the other scenario in which I have all the three orange colored balls. Okay, and if I play the same game with you, and if I ask you to select one ball out of these three balls, definitely the answer is going to be orange, orange, orange in any case, yes? So you already know the answer, you already determined the answer. So there is no any, you know, surprise factor or no any probability basically, correct? No any chances, all are winners, correct? So that is nothing but the deterministic experiment. And next to it, which we just did here, is nothing but the probabilistic or random experiment, in which you get more than one outcomes, like a random set of outcomes, correct? And out of which one is going to be, or one or more than one are going to be your events or your favorable outcomes, correct? What I am trying to tell you that in probability we always deal with random experiments. You get the reason for this now, because deterministic experiment you already know the answer, so there is no question of probability in that. Now moving forward to the events, okay, there are some types of events, very easy, okay, we'll go one by one. So first event is elementary event, okay, elementary event. The total number of outcomes for that event is only one, that is nothing but your elementary event. So N of E equals to 1 in this case, okay? So in our case, yes, this was the elementary event. Next is compound event, okay? Compound event, in which the total number of favorable outcomes of that event are greater than 1. In that case, that is compound event. For example, roll a die, okay? So roll a die means, you know that Ludo game, right? In which we have this die, correct? Dice, some people call it dice, die, singular is die, correct? So you have 6 sides to this, correct? 6 faces to this, have the 6 numbers on it, right? Not numbers but then dots, correct? 1 dot, then 2 dots, 3 dots, then 4, 5, 6 dots, correct? If you roll this die, so rolling a die is an experiment, correct? Rolling a die is an experiment in which there are possibilities of how many outputs? 6 outputs, correct? 1, 2, 3, 4, 5, 6, any can come. Any number can come there, right? So that is nothing but your sample space, right? But then what is an event? See, I tell you, the number has to be multiple of 2, or the number has to be even number for that matter, right? So that is an event. Event is what? Having even number on the front side. So event is going to be 2 or 4 or 6, correct? So there are more than 1 items in your sample, in your event right now. So that is nothing but your compound event, okay? When the total number of outcomes in an event are greater than 1, that is your compound event, right? When there is just one number, when there is just one outcome, that is your elementary event. Next is impossible event, okay? Impossible event. Name itself indicates that there won't be any item. This is basically the empty set event. Okay, n of e is going to be always 0, meaning that this set e is going to be always be empty, or it can be indicated that e is equal to 5. This is 5. 5 is nothing but your empty set. Okay, basically there is no any outcome from this event. Okay, for example, I'll tell you again. Say you rolled a die. Okay, and if I ask you, the event should be like, it should have the number more greater than 10, greater than 6 for that matter, right? Is it possible to have the number greater than 6 for a die? So it has 1, 2, 3, 4, 5, 6 only, right? Sample space has only these 6 numbers. But in the event you are saying that when you roll a die, it should have the number greater than 7, greater than 6, greater than 10. So no, that event is not possible. That is an impossible event. So this set is going to have 0 outcomes. That is indicated by 5. Okay. Okay. Now there are some more concepts which you should know. Mutually exclusive events. Okay. Mutually exclusive event. Now understand this. There are two events, for example, E1 and E2. So if you take intersection of these two events, you get the answer as 5. Means these are not impossible events. Each set has some elements. One or more than one outcomes are there for each of these sets. But when you take intersection to find out the common elements from E1 and E2, that is 5. For example, very easy example I'll tell you. If you roll a die and say first event is you should have even numbers. Okay, you should have even numbers. So what is the E1? E1 is 2, 4 and 6. And E2, say you should have the odd numbers. Okay, so E2 is going to be 1, 3 and 5. Correct? So when you take intersection of E1 and E2, do you get any result? No, that is going to be the empty set. So that is going to be 5, empty set. So these two events, E1 and E2, are mutually exclusive events. Okay. Now let's move to the next concept, that is exhaustive events. Okay. Exhaustive events. Again, say you have two events, E1 and E2. Okay. So union, when you take union of E1 and E2, that gives you sample space. That gives you sample space. Same example. Okay. Same example. If you take union of E1 and E2, what do you get? You get 1, 2, 3, 4, 5, 6 all. And what is there in the sample space? The same numbers, correct? So these two events, E1 and E2, are exhaustive events also. Clear up to this? Okay. So I hope you are clear, or you understood the basic concept of probability. What is sample space? What is event? What is the formula of probability? How we derive this, right? Then what is experiment, event, types of experiment, types of event, and these some more important terms. I hope these concepts are clear to you. Okay, then we can move further for the example. So these are the basics which should be very clear, and I try to explain in the simplest possible way for you. Okay, let's just quickly do some more orally only, some experiments and events, right? Say you toss a coin and you should get head. Okay, so tossing a coin is an experiment. Getting a head is an event. What is the sample space in this case? Tossing a coin, what is the sample space? It is going to be head and tail, correct? Either you will get head or you will get tail when you toss a coin. Yes, and what is the event? Event, they are directly saying you should get a head. Yes, so that is the event. Easy? Okay. Now one more example. If you toss two coins, then what is the sample space? I will write it down here only. Okay. So sample space when you toss two coins. One can be what? Head, both heads you can get. First head, second tail, first tail, second head, or both tails. Right? So this is the sample space. Now say for example, I say that the event is I should have both the heads. So what is the event? Say this is event E1. I should have both the heads. So this is the only outcome for this event E1, right? Say I say the second event is I should have at least one tail. I should have at least one tail. So what is going to be the outcome of this E2? Going to be HT, TH and TT also, correct? At least one tail means more than one tails are also valid, right? So this is event E2. Now let's see, I say that in E3 I should have exactly one head. I should have exactly one head. So what is going to be the outcome? HT or TH? You getting my point? Why am I doing this? Just to see if you understood the concept. If you can do this part very well, then you can solve the examples very quickly and also brush up the concepts of P and C, permutation and combination. This is the simplest chapter for you then. Okay, if you are good with this concept and if you're good with P and C, permutation and combination. Okay, so yeah, we'll solve some more examples about it.